Maybe someday in the future, Mars will no longer be known as the red planet that we know of today. The sky is a brilliant blue, clouds drift lazily overhead, and fields of green stretch out as far as the eye can see. Rivers carve their way through the once barren landscape, and cities buzz with life, a testament to human ingenuity and determination. This is the vision of Mars Transformed, a new world built from the ground up. But why should we even bother to transform Mars into a habitable planet? The most compelling argument would be that terraforming Mars offers the possibility of a second home for humanity, a new frontier to explore, exploit, and expand into. It could serve as a safeguard against existential threats to Earth, whether from natural disasters, pandemics, or other global crises. Moreover, the scientific knowledge gained from such an endeavor could revolutionize our understanding of planetary science, climate engineering, and even biology. However, the challenges are at a scale that we, humans, have never tackled. Mars has a thin atmosphere, no magnetic field to protect against solar radiation and temperatures that can plunge to extremes. Creating a breathable atmosphere would require vast amounts of resources and advanced technology. Most importantly, there is the issue of time. Terraforming Mars could take centuries, if not millennia, to achieve. The process would likely span multiple generations, requiring a long-term commitment and collaboration across nations and organizations. It's an endeavor that demands not just technological innovation, but also a vision for the future that goes beyond our immediate needs and desires. The idea of colonizing or terraforming Mars itself isn't new. Previous concepts and attempts have ranged from serious scientific proposals to ambitious and even whimsical ideas. Carl Sagan was one of the first scientists to discuss the possibility of terraforming Mars in his 1971 paper by vaporizing the northern polar ice caps to yield around 10 grams per centimeter square of atmosphere over the planet. Higher global temperatures through the greenhouse effect, and a greatly increased likelihood of liquid water. Films like Total Recall and The Martian have even captured the communal imagination, depicting worlds where advanced technology makes Mars a new home for humanity. Both past ideas and fictional accounts inspire real-world efforts and drive the conversation around what's possible. But the groundwork for terraforming Mars has been laid out as we speak. SpaceX, led by Elon Musk, is arguably the most ambitious. In 2022, Musk claims that a mission to Mars could be no earlier than 2029. Musk also envisions establishing a self-sustaining colony on Mars, a city that would serve as the first step in making Mars habitable. The plan involves not just transporting humans to Mars, but also developing the necessary infrastructure to produce fuel, water, and oxygen on the planet, paving the way for large-scale habitation. NASA's Perseverance rover is another crucial piece of this puzzle. Currently exploring Mars, Perseverance is gathering data that could be vital for future missions. The rover is also testing technologies like the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE for short, which aims to produce oxygen from the Martian atmosphere. Speaking of MOXIE, the instrument has proved to be a viable technology for astronauts on Mars to produce oxygen for fuel and breathing. Since 2021, MOXIE has generated a total of 122 grams of oxygen, about what a small dog breathes in 10 hours. At its most efficient, MOXIE was able to produce 12 grams of oxygen an hour, twice as much as NASA's original goals for the instrument, at 98% purity or better. On its 16th run, on August 7th, the instrument made 9.8 grams of oxygen. MOXIE completed all of its technical requirements and was operated at a variety of conditions throughout a full Mars year, allowing the instrument's developers to learn a great deal about the technology. Despite the progress being made, we still lack many pieces to this puzzle. For one, we need better methods of creating a thick, stable atmosphere capable of retaining heat and supporting life. Current ideas, such as releasing greenhouse gases or using giant mirrors to reflect sunlight, are still in the theoretical stage and face significant technical hurdles. Additionally, generating and maintaining a sustainable water cycle on Mars is a massive challenge. While there is evidence of water in the form of ice on Mars, we would need to figure out how to melt and distribute it efficiently across the planet. Moreover, we're still in the early stages of understanding how to grow food and create a self-sufficient ecosystem on Mars. While the dream of terraforming Mars is still far from reality, the journey has already begun. The missions and projects underway are laying the foundation for what could be humanity's greatest achievement, turning a barren planet into a new world. But let us know in the comments how you think Mars will look like once we successfully terraformed it.